Today I would like to talk about mixtures and compounds. Now, a compound is a material that is composed of chemically bonded elements. Elements are pure materials. Gold, every atom in a piece of gold is a gold atom. Elements combine together chemically. Hydrogen an element, oxygen an element. If you combine them chemically, you get water. That is a compound. On the other hand, there are mixtures. Mixtures are not bound together chemically, they are just physically mixed. For instance, you could have a pile of salt and a pile of pepper, and you could physically separate them. If you use some static electricity, build it up on a comb, you can run it over and the pepper will separate from the salt. If you had iron filings with rice, you could separate out the iron filings with a magnet. Another form of mixture is something called a solution. A solution is a solid mixed in with a liquid, where they're said to dissolve. The thing that gets dissolved, for instance salt, is called the solute. The thing that does the dissolving, the liquid, is called the solvent. You mix the solid solute into the liquidy solvent and you get a solution. You can mix salt and water together, dissolve them, and you can separate them using a physical means. You can boil the salt water. You will leave the salt behind, and then the water will turn into water vapor, go up, condense, and fall back as water. You can separate the salt and the water with a physical means, boiling, a magnetic means, an electrical means. A physical, you could take tweezers and separate out the salt from the pepper. Now, some things will not dissolve. Water is called the universal solvent because it dissolves almost anything. It's because of the polar nature of the water molecule. It has a positive pole and a negative pole. The oxygen grabs most of the electrons and gets very negative. The hydrogen loses its electrons and gets very positive. And because of that structure of having a positive pole and a negative pole, water can dissolve anything that is polar. And most things are. So water is considered to be the universal solvent. Now, when something is immixable, it means that you cannot make it turn into a solution, that the two materials will not mix. The most common example of that is oil and water. I, for instance, have here 1, 2, 3, 4 oil, 1, 2, 3, and 4 water. Oil and water do not mix. Let's see if that's true. We'll take the bottom layer is oil, the top layer, of course, is water. We will take and separate water, 1, 2, 3, 4 waters, and the oil, 1, 2, 3, 4 oils. So now let's mix the two, water and oil, water and oil, water and oil, water and oil. Now, because they're immixable, if we wait long enough, the oil will rise to the top because it's less dense. The water will fall to the bottom because it's more dense. We'll take our top layer, 1, 2, 3, 4, and our bottom layer. Now our top layer has become all oil. 1, 2, 3, 4. That's oil on the top. And water has sunk down to the bottom. Now, what we could do is separate them and do it again. This time, so there's no funny business, let's do it face up. That should be fairly easy. So now we'll do the water face up, 4, face up. And now let's mix them again. Oil and water, oil and water, oil and water, oil and water. Once again, we let them settle for a while. They'll mix. The less dense, the lighter oil will go to the top. The heavier, denser water will go to the bottom. It'll give me my top layer, 1, 2, 3, 4, and my bottom layer. Once again, the top layer is separated out. Oil on the top, water on the bottom, oil, and then water. We have water and water. We have water and water. Once again, they separate. But what if I wanted to make them stay together? What if I was going to make, say, mayonnaise? Now, mayonnaise is a mixture of vegetable oil, canola oil, olive oil, and the watery part of the egg. Those two should stay separate, but they don't. It's because with the oil and the water, there is something called a emulsifier, in this case mustard. The mustard is an emulsifier. It contains the material lecithin. Lecithin is also the emulsifier that makes the milk and milk chocolate stay mixed with the chocolate in milk chocolate. They are forming something called a suspension or a colloid. It still is a solution. It still is a physical mixture. In theory, you could separate them. So, you know, it just so happens that I have some mustard right here in my pocket. So if I use that emulsifier, then it will let the material, the mixture stay oil and water, oil and water, oil and water, oil and water, keeping my suspension, my colloid, together. And that's what I wanted to talk about with mixtures and compounds.